Start with a short review before you do today's lesson. As a reminder, slope, we've talked about this before, a lot about it, so you should have a pretty good idea. Remember, it's that change in y, that vertical change, the rise, over the change in x, the horizontal change, or the run, we call it. Also want to remind, so I should write a number here first. So if I had 4/3 as my slope, that means I'm going to go up 4 over 3, right? So on a graph, it would be something like, let's say I started here, right? Go up 4 over 3, put another dot, that sort of thing. So, and we'll do several examples of this. I also want to remind you of slope of 0. Okay, anytime you see a horizontal line, that's a slope of 0. We even did the math example here, like here, you go from here to here, right? So the y component, here and here, so 2 minus 2 is 0. The x component, here we have 1 minus the negative 3, so 0 over 4, which we all know that's 0 divided by 4, which is 0. So a horizontal line has a slope of 0. A vertical line, perfectly straight up and down, not just kind of, but perfectly straight up and down, is an undefined slope because we're not allowed to divide by 0. And again, what's that look like? Well, if we look here, we have 1 minus 3, so 1 minus 3, over negative 4 minus negative 4. Again, the x component's on the bottom, which is 0, so negative 2 divided by 0, we say is undefined. You don't have to know the reason why. It's just, there are lots of reasons, but the main reason is in math, anytime that we run into something that we can't explain or has more than one answer, like this case, there's more than one answer that really makes sense. And I have a whole video on that. If you want to see it sometime, let me know. But anyway, the idea is dividing by 0 is undefined in math. Now this part we've done before too. So finding the slope for each line, this is just counting. So if I go from here to here, remember we always say go from left to right with slope, left to right. So this goes up 2, that's here, and over 1, 2, 3, 4, that's here. So again, it's the rise over the run, that's 2 over 4, which is a perfectly wonderful slope, which always reduce that fraction to 1/2. Another example, this one going down from left to right. Remember the running pig, anytime you see going down from left to right, that's going to be a negative slope. So this one, again, the down part, right, is 1, 2, 3. That goes on the top, negative 3 because it goes down. And the bottom's always going to be positive because we go from left to right. So 1, 2, so negative 3/2, and that's it, negative 3/2. It doesn't reduce, so there you go. Again, counting slope, we've done lots of that. Just a quick example for you. Head into class kick and do that. I'm going to be watching. So the one you should have done in class kick here. What is the slope of the ski trail? Down below here. So again, rise over run. This one goes down, right? The slope that goes down. So it's going to go down by 1, 2, 3. So that's negative 3. It's going to go over then by 1, 2, 3, 4. So our slope is negative 3/4. That does not reduce. Continue watching for more examples from me. Alrighty. Now, as we discussed before, and you have practiced the heck out of this, finding the slope using the coordinates, right? So using math. And it's that change in y over change in x that we want. And remember, we discussed this too. It's important to remember that, it doesn't matter which point you pick as point 1 or point 2. What matters is that you stick with it. And I'm going to leave this example up here. I'm actually going to go backwards from this. Before I do that, though, I want to remind you of the formula, right? Our formula for this, for slope, is y2 minus y1 over x2 minus x1. And it looks like what they've done here is they have decided that point 1 is going to be the point negative 2, 6. This is evidenced by right here, right? So they pick this as point 1. I'm going to do the exact reverse and show you we get the same thing. So I'm going to call this point 2, this point 1, okay? And that makes this right here x2, that makes this x1, this is y2, and this is y1. Again, I'm doing mine exactly opposite so you can see I get the same answer. So my y2 is going to be 3. My y1 is, oops, I did it backwards. Hang on a second. My y2 is actually going to be 6. All right, my y1's going to be 3. Almost did the exact same thing they did. But anyway, my x2 is going to be -2, and my y2 is going to be 4. And so we get 6 minus 3 is 3 on the top. -2 minus 4 is -6 on the bottom. And that does reduce to negative, or you could say 2 over, or 1 over -2, we could say, which is actually still -1/2, right? There you go. So again, it doesn't matter if you switch it around, as long as you switch the whole thing around. You can't go mixing around and put y2 minus y1 and x1 minus x2. You got to be consistent. That's why I always pick the points 1 and 2, and then do the math. Pause, head into class kick. There's another one for you. So again, finding the slope here, reminder of that formula, y2 minus y1 over x2 minus x1. And again, I'm going to call this here x2. That makes this y2, x1, y1. Okay? So on the top, my y's, we're going to have -1 minus -7. In the bottom, we're going to have 8 minus 0. This is where you really got to know your integer operations, right? That double negative thing. So on the top, I'm going to get, let's see, -1 plus 7, really. Once we cancel out those double negatives there, that's going to give us 6 on the top, and 8 minus 0 is 8 on the bottom, which does reduce to positive 3/4. Again, if you get stuck there somewhere, take a look at it. Come and ask me questions. Go ahead and keep watching for more examples from me. Now, you've done a lot of this too. Just a review of this again today. Interpreting slope for real world, right? Obviously this isn't real world, but, using the slope in a story problem. A store sells sugar in bulk for 25 cents a pound. Graph the relationship, pounds of sugar over cost. Compare the slope of the line through the points on your graph on the ratio. So, obviously, if you buy 0 pounds of sugar, you spend $0. 1 pound of sugar, 25 cents. 2 pounds of sugar, 50 cents. 3 pounds of sugar, 75 cents. 4 pounds of sugar, $1, 100 cents, right? It's funny to think about it that way, 100 cents. But anyway, so use 2 points, right, to graph. And again, you know that 1 pound, right? And then you can go back and calculate, 1 pound is 25 cents. You can go back and calculate the slope. Pick any 2 points. In this case, we picked this point right here, which is 3.75, and this point down here, which is 1.25. Okay, and throw those numbers in here. 75 minus 25 on the top. 3 minus 1 on the bottom gives us 25 over 1, or the cost is 25 cents per 1 pound of sugar. Oddly enough, you find the slope is the ratio. That's going to happen every time. Pause, head into class kick. I've got one for you. Alrighty, so same thing here. Find the slope of the line determined by the relationship inches to feet. And I make inches my x here, since notice inches, feet, x, y. That's why I picked that, because it was already given away right here. X comes first, y, so inches, feet. Which is crazy, because when you think about slope, the y goes on the top. Got to remember that. It feels a little bit backwards sometimes. But anyway, so we know that. Now, this is going to have a little fun with this one. We know that 0 inches is the same as 0 feet, right? So I have my point 0, 0. We know that 12 inches, and let's count that. We know that 12 inches, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 inches is 1 foot, right? So 12 inches is 1 foot. Now, if I wanted to graph another one, I'd have to have this thing be a lot longer, right? Another 12 inches goes up to 2 feet. But I already have 2 points here, and I'm going to go ahead and connect the dots with those real quick to make our line, right? And I'll switch colors on it here. And it'll look something like this, like that, and it'll just keep growing. So if I had 2 points, though, again, you could count the slope here. You can calculate the slope. But in this case, I'm just going to count the slope because it's pretty easy to do. So I change in y, which is 1, goes up 1, and goes over 12. So my slope is going to be 1/12. Go ahead and keep watching for another example from me. Now, I know this has been in your vocab. We're going to kind of put it down today, finally. How to use the slope to graph a linear equation. So we have this slope-intercept form of a line. We talked about that in your vocab. Y equals the slope, that's m, times x, plus b, this number here. This number b right here, I will give you a hint, is seriously a point. This point 3 is the point 0, 3. If it was 4, it'd be 0, 4. If it was minus 6, it'd be 0, negative 6. Okay? And then the slope's given to you here. So I'm literally giving you a point and a slope all in one here. That's why it's called the slope-intercept form or the y-intercept form of a line. And if I take a quick look here at this one, I've given you the slope of 1/2 and the y-intercept, which we've talked about what y-intercept is. That's where we cross the y-axis. It's the point literally 0 and whatever this number is. So in this case, it's the point, I'm going to switch here to every different color. Switch to point 0, 3. Okay, because again, that looks like y equals m, that's the slope, times x plus b. That information I have down here for you as well. The slope-intercept form of the line. Alrighty, so what that means is I can literally take this point right here, graph it, 0, 3. I'm going to do that right up here. And then I can go ahead and count the slope from there. And my slope is negative 1/2, right? So down 1 over 2. Down 1 over 2. And we can graph those other points. And then connect the dots. It all comes from this very simple form of the line. That's it. And we'll do another example here, a couple of them actually. Okay, so again, here's what we're doing. A ramp slopes from a warehouse door down to a street. This equation, y equals negative 1/3 x plus 2, models the ramp, where x is the horizontal distance in feet from the bottom of the ground, and y is the feet above the ground, or above the street rather. Graph the equation. So again, as a reminder here, this has all the information we need. I'm going to get this out of the way just a little bit so I can write it down. It is y equals negative 1/3 x plus 2. Okay, this number right here, the plus 2. Now, if that was negative 2, right, that would be the point 0, negative 2. This is a positive 2, so it is the point 0, 2. And I already give you the slope right here of negative 1/3. So all we do to graph it is go to the point 0, 2, right here, and then we count the slope, down 1 over 3, and put another dot. And then we just connect those two dots. Oops, that didn't turn out right away very well, did it? Get rid of that, and then there we go. Okay, so apparently I can't graph a straight line free-handed. But again, you play connect the dots, you get the idea. And that's it. That's all there is to graphing from this. It's one of the nicest things we're going to do, as long as your line is in this form, slope-intercept form. Go ahead and pause, head into class kick. I've got another one for you. I actually had two for you here. So, again, the information here. We have a slope of 2, so m, that's the slope, equals 2. Our point, 0, notice there's a negative this time. So our point is 0, negative 3. So we go and graph that. Over here, we graph the point 0, negative 3, right there. Then we count our slope, which is 2. So up 2 over 1. Okay, you ready? So up 2 over 1. Do it again if you want to. It makes you feel good. Up 2 over 1. And then all we do is, you can count it all day long if you want to, right? Then we just go ahead and we play connect the dots and make a straight line going through all those points. And that's it. That's all there is to it. All the info is given to you right there. Let's do another one. As a reminder, by the way, when you see a negative in front, there's a secret 1 there, right? So our slope this time, let's pick a nicer color, m equals negative 1. And our point is 0, positive 4. So we graph the point 0, 4. We count our slope negative 1. Down 1 over 1, right? Down 1 over 1. Down 1 over 1. And keep going. You can count it backwards if you want, which is, just kind of follow the line backwards. And then we just connect the dots all the way through. And that's it. All the information is right there in slope-intercept formula. Okay, you have a little bit of homework today, straight out of the book for this. And tomorrow, so we're going to do the evens one day, odds the next, right? I think the first day we'll do we're going to do the odds. So it's on 402. 5 through 19 the odds, and we'll do the evens tomorrow. So.